Hi, I'm Dana Myers with the Wireless Connectivity team at Texas Instruments. Today I'm going to give you a technical overview of the SimpleLink Wi-Fi CC3000 solution. So today, from an agenda perspective, we're going to talk about CC3000, an introduction to the solution itself, a little bit about the specifications, then we're going to go into the hardware offering, software offering, talk about the software architecture itself, we're going to talk about porting guide, and then have some call to actions. So let's get started talking about the CC3000 Wi-Fi solution. So this is a great solution that is basically a self-contained Wi-Fi solution, has very simple APIs, low MIPS, low CPU overhead, and a very low memory footprint. So basically bringing Wi-Fi to the MCU world. So some of the key software features that we have in this solution, number one is Smart Config. This is a proprietary differentiated solution how you can in one step configure the CC3000 solution for your access point that you have in your home or wherever you're using the product. Flexible memory size, so it allows you to use very low MCUs such as TI's MSP430 value line, or if you want to use all of the APIs or larger buffer sizes, you have flexibility to do that. Service discovery, so when people in the market start using these type devices, they're not going to want to look at it from an IP address or understand some of the details. They're going to want to be able to understand it as their product itself. And then cloud enablement, so if we think about how we do things on our phone, the applications, we're accessing things in the cloud, our data, the information, and that's enabled on CC3000 as well. It's offered today as a module, the CC3000, and samples and production units are available today through TI and distribution. So let's talk about enabling the Internet of Things. So we hear these buzzwords all over the place, the Internet of Things, the Internet of Everything, and it's really how do we bring Wi-Fi solutions into the market. You see a lot of applications there on the bottom showing smart plugs, showing health and fitness devices, home appliances, lights, different things like that you're going to want to monitor, control, do different things with in the world as we get into the Internet of Things. CC3000 is making this a reality. All right, let's go into the hardware offerings. We're going to talk about this a little bit. What is a hardware offering of CC3000? So start off here from the TI module itself. So you see a block diagram in the picture. So starting off with the wireless network processor. So it supports IEEE 802.11b and G. It has an embedded TCP/IP stack and supplicant. It contains and allows you to use 4 different sockets, either UDP or TCP. So that's kind of the fundamental wireless side of it. And then from a radio performance perspective, coming from the history that TI has had from the Wi-Fi side, great performance. Your transmit power being plus 18 dBm, your receive sensitivity minus 88 dBm. And then from a system perspective, you have active modes, so you have a crystal that supports the active modes, and then you have a slow clock that supports the shutdown, very low power, less than 5 microamp mode. Then a couple other solutions, that the level shifter as well as the DC to DC that allow you to work in a system that's 3.5 volt, which is typically what we're seeing in the MCU world that this is supported in. And then you have an EEPROM. So this is used for configurations. You're going to have your wireless LAN configurations, IP address, any radio parameters. User files can actually be in there as well, and flash code. So some memory in there that allows you to do some configuration and fixes as needed. So one key point here that we show in the bottom is this solution, this module itself, is offered at $999 for 1K. That's a really good price from a Wi-Fi solution that's integrated like this and easy to use in the MCU world. So let's talk a little bit more. There's some more features that we want to talk about for the CC3000 solution itself. So one is, I talked about pairing with low memory, but what does that really mean? So being able to have the base driver and the fundamental code that's required can be as low as 2K of flash and 251 bytes of RAM. So you can use a really small MCU and still add Wi-Fi to your system. The size of it, from a competitive standpoint, the size is quite small for the module, which means that your system layout, board costs, and things like that can be reduced as well. It's also fully certified, so it's certified from an FCC, IC, CE, and TELEC perspective. That allows you to save up to around $30,000 from a solution because it's modular certified, so you can take that and use that in your own solution. And then implementing Wi-Fi. So if you're coming from the embedded world, if you're coming from the web world and you don't know RF, you don't want to learn RF, this is a great solution for you to bring that type of technology into your systems, into your products, without having to gain or hire that kind of expertise. So we talked about MCUs, and this is bringing Wi-Fi to the MCU space. So let's talk about that a little bit more. So first off, from a TI perspective, we have a great portfolio of MCUs. We have MSP430, really ultra low power microcontroller. There's hundreds of those that can be used along with the CC3000 to create an implementation. We also have other solutions such as the TVC ARM microcontrollers, which there's several of those as well that can bring in a little bit higher performance, a little bit more memory, but do different kind of things. And because of the flexibility and the small driver, the ease of porting, it's very easy for CC3000 to be used with any of these microcontrollers. So that in mind, there's also options if you already have a different MCU within your system and you want to use that. We have a lot of information on porting and how to do that. We'll talk about it in some more detail later in this presentation. All right, let's talk about the software offerings. So we've gone through the hardware a little bit. We've looked at the module, what's inside the module. Let's talk about the software. So this is giving kind of a preview of the software sample applications that we provide. So TI is not only providing the module itself, but we're bringing with that a lot of documentation, detailed information, and software examples. So that allows you to get started right away to do some of your development. You can use that as base code to then develop your own applications around it. So I'll go through a little bit some of these applications. The first one is the basic Wi-Fi application. This is actually supported on several different TI platforms, and it's very simple. It's just an application that has the SPI driver, allows you to do a connection over Wi-Fi and send a little bit of data. So it's very simple. That's why we call it the basic Wi-Fi app, but supported on several different platforms. So you see here in this table, it's showing you the application itself, the platforms where it's supported, a brief description of it, and then links and information to the documentation. So the second one is a simple email. So this is actually very cool that you can actually send an email from an FRAM device. MSP430 FRAM sending an email. So a sample application, how to do that, how to be able to tell somebody, here's an email saying hi from a CC3000. So sample code there on the FRAM solution. The next one is a simple HTTP server. So this is really creating a web server on an MSP430, the 5529, where you can then have information on there. You can get notification if something's happening, or you can change information, control what you're doing on your platform itself. So it's very powerful. You could see using that in several different applications. The next one on the TVC series is an SMTP, or Simple Network Time Protocol. And this is really showing very accurate time in a sample application using CC3000. The next one, which is kind of one of the overarching solutions that we have, is showing home automation. So how would you, if you're seeing the Internet of Things and those kind of things that are coming about, kind of implement that from a Wi-Fi perspective? And that home automation is going to give you a feel for that. With an application on like an Android device, and then you have the ability to change and control things over Wi-Fi itself. The last one is a new piece of the implementation that we brought in, which is enabling multi-thread. So that allows you to use different RTOSes. The implementation and example that we've done on the TVC uses the TI RTOS, but it can actually be used with any RTOS. So let's start talking about some of the key features with the CC3000, and we'll go into a little bit more detail. We talked briefly before about Smart Config, but let's go over that in some more detail. So what this is intended is really to create a great user experience for the Internet of Things applications. As the users are going to be bringing in these type of solutions into their homes, into their places where they're going to be using them, they have to very easily be able to connect to their access points. So kind of the problem statement would be that most of these type of applications, like if it's a smart plug or things like that, there's no display, there's no keyboard, there's no way to input things to it. So TI has come up with a proprietary way to be able to very easily, in one step, do that configuration and tell the CC3000 based device how to connect to the access point. So a couple key things there. We really see this as a differentiator. Some of the other solutions that I'll compare to a little bit later in the presentation will show you why it's a true differentiator. The other piece is that we have sample implementations on Android, iOS, and even Java applet for the PC that customers can then take and modify and bring into their own solutions. So some of the key pieces here, it's really just a one step. You're not having to do a whole bunch of things. You're not having to know a lot of the technology and terms and things like that. So it's very easy to use. You can do multiple devices. So say you're buying a smart plug, you may not just buy one, you may want to buy multiple. And being able to configure those at the same time is great. Also, configuration, it's secure. So allowing, if you're sending your information about your home access point, you want that information to be sent securely. You don't want it to be broadcast into the air so that anybody can get a hold of that. So let's look at that a little bit more detail. So I talked about the sample implementations, and these are some visuals to show what the apps look like. So on an iOS device, this is available in the App Store itself. And then we also have on TI.com a downloadable for the source and the library that can be used in your own application. We also have an Android solution that's available on TI.com with the source and the library that's downloadable. And then a Java applet as well. So this is available both live on TI.com, where you can just try it out there, or it's also a downloadable that can be used and customized into your own applications. So I talked a little bit about the security side of things, and I think this is really important to make sure that it's known that if you're sending that information about your access point, you really want that to be secured. So it's done with AES 128 cipher, and this encrypts the information. When CC3000 is receiving the information, it knows what it's doing, it decrypts it, and then uses the information to connect to the access point. So I talked a little bit about how this is really a differentiated solution. So let's compare it a little bit to some of the other solutions that are out there in the market for Wi-Fi applications and connecting to the access point. So the first one is, where can you use it? Where can you do the connection from? So the first one from TI Smart Config as well as AP mode can be done from a phone or from a PC. WPS is going to be specific to that type of an access point. So it's going to be an access point that has to enable that protocol and that feature, which not all access points do. So what about from a network? Does it work with any network, any home, things like that? So Smart Config and AP mode do that. WPS, again, that's going to be specific to an access point that has a WPS feature. All right, how about how many steps? I think about my mom buying a smart plug, or my grandmother, and they're not going to want to go through a whole bunch of steps and connect and disconnect and do things like that. And that's part of the major differentiation. Smart Config is really one step. Some of the other solutions like AP mode are going to be multiple steps. WPS is also one step, but again, you go back to having that specific kind of access point. All right, what about, we talked about if you have multiple products that you want to configure at the same time. Smart Config allows you to configure those at the same time. We were in a class and had the ability to program and get Smart Config working with several different people within the class at the same time versus doing one at a time for each one. The other one is it easy to use? Can you just stay connected? You're at home with your phone, you're already connected to your Wi-Fi access. Do you want to have to disconnect that and do different pieces and then come back and reconnect to that? Not likely. With the Smart Config, you don't have to do that. With the AP mode, you do have to do that. And then the last piece, we talked about being secured. So that's an important piece when you're talking about transferring your information into the air for these configuration solutions. All right, let's talk about another feature. So MDNS. So there's kind of two pieces to this. One is self-advertisement. So CC3000 has the ability with MDNS to self-advertise that it's there. So it's connected to an access point, and it's advertising the service via multicast packets. So the type of information that it's broadcasting or advertising is going to be like its device name, its IP address, maybe who the vendor is, the port number. And this can be done with different kinds of solutions where they're just showing that these solutions are there. Any device that's listening within that network can connect to these clients itself. So let's talk about service discovery. So also a part of MDNS. If you think about, if someone's using a printer or a smart plug like we have here, the user is not going to go in and remember the IP address or want to see it from a very technical perspective. They're going to want to go in and say, I want to connect and control my smart plug or my printer. And being able to use the standard service discovery solutions that are out there where it's implemented and shown those specific names, it makes it very easy for a user to implement. Okay, let's talk about the flexible memory size. We mentioned this a little bit, but let's talk about it in a little bit more detail. So the flexible memory has compile options. So this allows you to configure it depending on what your system requirements are, what kind of MCU you're using, and things like that. So let's look at it from where some of the flexibility is. On the flash side of things, it really depends on which APIs you're using. If you're doing a very simple application where you're just sending a couple bytes of data or something very small, then you can only use a couple of the APIs and have a smaller memory set. On the RAM side of things, it depends on how big your packet size is. How big do you need it to be for the application and the kind of information that you're sending? So that's kind of the default side of things. And we look at the tiny driver, which is really kind of a small implementation, the lowest footprint, some limited capabilities because it's trying to get that memory really, really low to bring CC3000 to literally any MCU. And so the main driver side of that is going to get down to as low as 2K bytes on the flash and 251 bytes on RAM. So that's really, really low. You can use that with just about any kind of MCU. Obviously, the final code size is going to depend on which APIs you use and that you compile in. And then RAM is really dependent on the packet size that you're sending and receiving. All right, let's start talking about software architecture. Let's go through this a little bit, kind of where things are coming from and some of the other Wi-Fi implementations and where we're looking at it from a CC3000 perspective. So let's start here. This is kind of a picture of a more traditional Wi-Fi solution where you're going to have a larger MPU like a Sitara solution where your stack, your TCP/IP, your Wi-Fi management, all those things are going to be on the MPU itself. This is typically a system where you're running Linux or some kind of high-level OS. So as we come down on the bottom and we're showing it from a CC3000 perspective, we've brought all that stuff inside the CC3000 itself. So that's why it makes it so easy to work with the lower MCUs. Basically all you have on there is API, you've got a CC3000 driver, and the hardware interface, which is SPI. So very low code that we're talking about. It also brings a lot of simplicity to the solution. You're not having to understand how to work with that code on the MPU or MCU itself. All right, let's look at the APIs a little bit and get into a little bit more detail. So there's different APIs that are supported with the CC3000 itself. So the first one here, there's some wireless LAN APIs, and these are used to talk to the protocol itself, the 802.11 protocol, which is standard wireless LAN protocol. So there's some examples there of those APIs. The next one is really what you're using from the application level, your BSD socket APIs. How are you interacting and doing things within the system itself? If you've worked with standard BSD socket APIs, it's very easy to use with CC3000 because it's using those standard socket APIs. There's also some network application APIs. So this includes some of the networking side of things. If you're doing things like DNS or ping, some of those more networking type applications or activities, that's what these APIs are going to be used for. And then the last set, the NVMem, is really talking to the EEPROM that we talked about near the beginning of the presentation. So if you're working with that EEPROM, if you're going to put some of your own code there, if you're updating the patches and things like that, that's where these APIs come into play. All of the APIs are above the HCI layer, and they're basically meant for kind of a a hardware abstraction layer. So how do you get more information on the APIs? If you go to TI's wiki, which is www.ti.com/connectivitywiki, and go to the Wi-Fi solution, you'll see here at the bottom the API documentation is there. So it's basically a Doxygen HTML, and there's an example here at the bottom that shows you the different APIs themselves. It shows you the parameters, it gives you some descriptions, and so it goes through a lot of detail on the APIs themselves where you can get that next level of information. All right, let's talk about kind of a typical command event flow as you would work with CC3000. So we'll just go through this as an example, and this just kind of gives you some of the key things with some of the APIs that we have talked about. So the first one, starting with initialization. So you're going to initialize the SPI and the CC3000 driver. You're going to start wireless LAN itself. And then you're going to set up the IP address configuration. So using DHCP for dynamic IP, or you can do it static IP. So having an API for that. And then doing the association. So we talked about smart config, being able to do that. You can either use existing profiles. So if you already have this solution connected in your system, it's going to remember that profile and information and try to connect to it automatically. Or you can do things manually from the MCU to tell it, here's the information that I want to connect to, or using the smart config solution. And then creating a connection with another network device. So this is where you get into the BSD socket APIs. You're going to open a socket, you're going to connect or accept the socket, then you're going to send some data with the MCU, handle the connections and sockets, and then you're going to disconnect and go into reset off state. So that's kind of your simple, I'm going to get up and going, I'm going to connect, I'm going to send some data, and I'm going to shut back down. So pretty simple. You don't have a whole ton of APIs. It's not thousands of lines of code. It's pretty straightforward. Okay, let's talk about the patch programmer. So we talked a little bit before about the EEPROM, and there are patches on that if there are any system issues or bug fixes that are implemented. So let's talk about how the patch programmer fits into that. There are actually two methods to update that patch into the EEPROM itself. One is without an IDE, using the patch programmer utility. So TI has this available online for the different platforms that we support. And so it's very easy to use the patch programmer and download directly into the EEPROM itself. There's also other methods through the IDE, either IAR or CCS, that you can download and bring the patch into the solution. So just from a high level perspective, there's a lot more information on the wiki and details about it. But the download, if you're doing the patch programmer, it'll download two steps. One is a driver patch, which is what you're putting onto the MCU itself. And then the other one is a firmware patch, which is actually going into the CC3000 solution. All right, let's talk about the porting guide. So we talked about the plethora of MCUs that TI has to offer, and then there's many options that can be done. We have a lot of software implementations that are done on various TI MCUs, but maybe your system doesn't have a TI MCU. So there's options there for you as well. Okay, let's go through a little bit on the porting steps that you would use if you were going to do porting. So the first things there are really writing a platform-dependent SPI driver, so what's specific to the hardware that you're using, and then mapping the SPI and GPIO lines to that MCU itself, so connecting those with CC3000. So there's several references that we've talked about. There's sample code for different types of processors from the TI side. There's reference guides from the hardware side, your data sheets, user guides. There's even a porting guide. And then you can also use things like for debug purposes, oscilloscopes and things like that to get through. Within the platform-dependent code, there's a couple things just to keep in mind. One, the GPIO, making sure that is implemented correctly. The SPI lines, making sure that's implemented specific to the MCU that you're using. And then some of the platform definitions, making sure that those are done correctly. The configuration files for sections of definition. The mapping of the memory may be different between some of the MCUs for like your transmit and receive buffers. Your interrupt vector routines and system clock, making sure those things are configured correctly for the particular MCU. All right, call to action. So what's next? Now that you've seen CC3000, you've seen some of the differentiation, how it brings the Internet of Things to the world, what's next to do? So the first one that we have here is a CC3000 EM, and this is a daughter card with a CC3000 module on it that works with TI's MSP430 experimenter boards, as well as Ativa experimenter boards. So you see there on the list the ones that it's compatible with, and then we have some software implemented with. The MSP430 F5529, the MSP430 FR5739, and the Ativa C TM4C123G experimenter boards. So we also have a booster pack. If you're more familiar with launch pads and the booster packs from TI, we also have that option. Same CC3000 module on top of it with just a different interface into the boards. So this works with TI's launch pads, both MSP430 value line as well as the Ativa C TM4C123GX launch pads. We also have a couple bundles, so if you're looking to buy the boards together, say the launch pad along with the booster pack, we have some bundles there that are available at a discounted rate. So when would you use an MSP430 versus a Ativa solution? If you kind of look at the overall picture of things, MSP430 is really focused on the ultra low power portable type applications. The Ativa C gives you a little bit more memory and power in the MCU itself, working on home, building, commercial, industrial type markets. So you have various options there that you want to work with. So there's some more information, wanted to give you some resources to go look at if you want some more details as well. So the first one being the extensive wiki. So we showed that a little bit when we talked about the APIs and the documentation there. The wiki itself really takes you through how do I get started, what's the details on the hardware with reference designs, more details of the hardware that we went through itself, software implementations, where are the downloads, where's the documentation for the software, and then getting into details on how you're going to use it if you're going to production. How do you reuse the certifications? What kind of design checklist do you need to have to make sure that you have first pass success? So there's a plethora of information on that wiki that you can get to from www.ti.com/connectivitywiki. There's also more information on TI's product pages. So if you go to ti.com and search for CC3000, you're going to find the product page that'll give you data sheet, design files for the hardware designs that we talked about, evaluation information for the kits that we talked about. And then from a download and installation, so we talked about the implementation with IR, with CCS, also have the API documentation, and then all the sample code, demos, applications, and things like that that are available for download, free to you to use as a starting point for your own development. And last but not least is really the support community. So if you start doing implementation and you want to get help from our engineers, this is how you would do that. So come to our E2E forum, you can ask questions, you can work with the community and get answers to the questions that you have. So thank you for listening to this presentation today. Hope that you have some more information about the CC3000 and can get started today. What will you connect?